Hello team, today's challenge is Roman numeral fixer, where we're given a Roman numeral that is a mistake, right? There's too many I's in this one is backwards, too many of bunches of characters in a lot of these, and the last one is just, I don't know what's going on there, but it is all over the place, right? We need to untangle these, and then we need to create them. And the easiest way to do this is going to be to actually calculate what this value should be as a decimal number, and then redo it or rebuild it to the correct number. Thankfully, they have allowed us to do that. So the number being passed in will only ever use additive notation, right? So in this case, it'll be 10, 11, 12, 13, 14, 15, right? This is 1, 2, 3, 4 plus, what is that? 50 plus 10 is, well, that would be 54, 64, I believe, right? So things like that, we're going to figure all that out. And then we are going to, when we rebuild it, then we're going to have to take care of those subtractive pairs where a lesser numeral can come before a greater numeral, right? Again, the easiest way to do this is to parse it, get a number, and then feed that back out. And for the second part, we'll actually be using code that we've already seen inside of Roman numeral builder, which was from last December, December 11th, I believe. So we're going to review that part again too, okay? Over to the code. We start out with our data. And I've talked about this in that previous video where I like to use the exact same data because it's highly unlikely for Roman numerals that we would be doing parsing but not building, or vice versa. And so having a single set of data that we can use to get that job done just makes our lives easier. Even if we aren't using the subtractive pairs or there are certain things in here that we'll just never use, right? It's just easier. One set of data, and that way we can use it everywhere, right? Now for this, I do want to access these as keys. I have it as an array, as a series of arrays, right? Arrays inside of an array. And I want to access these keys instead of having to do a find. So for that, what I like to do is I will set up a numeral map, just like this, and send in new map with the numerals, right? And that will let me do that. So now I can do numeral map.get I, and it will return the value of 1, right? If it exists. With that, we can actually get started. So the first part is to calculate the total of the incorrect string, right? I'm going to build out a new function for that. We're going to call it parse bad Roman, like this. I don't know if that's a good name or not, but we'll run with it, okay? And then inside of here, we're going to calculate a total. So let output equal 0, just like this. And down here, we are going to return that output. Excellent, okay? Now right here, we can do a for loop, okay? And that for loop is going to be on the string. So we're going to let letter of string. And for each one of those letters, because it's only ever additive, each letter will be whatever its value is. So we can go output plus equals whatever that is. It's going to be that numeral mapped. We can just grab that, dot get, and we are going to pass in letter. Now, my question here is what happens if our string includes non-numeral letters, right? Maybe they include the actual letter O for whatever silly reason, or the actual letter Z. I don't know why they would, but maybe they do, right? And as a way of doing that, we could theoretically, we don't have to today, but if we wanted to, we could just designate all those as 0. So if we find a match, we use that value. Otherwise, we just return 0, which is totally an option, right? We won't have a way of testing this today, but it's there, okay? From here, we can go and grab that, grabbing the whole thing because I use the same argument. And right down here, we set up the number, okay? So const num equals parsing that bad Roman string to something else, okay? With that, now we need to take that number and rebuild the actual Roman numeral, right? Whatever that is. So again, this is the one that we've seen before. So function to Roman, okay? And we pass in our number, okay? From here, we do stuff. So we're going to calculate a string, which means that we need Roman. That's going to be equal to an empty string. That's actually what we're going to return. So we can just go down here and go Roman. And then right here, we do another for loop, right? We want to iterate on the number to build out that Roman numeral, right? So we're going to do let this array of what? Well, it's going to be numerals. In an interesting twist of fate, we could actually loop over numeral map, right? But numerals has everything that we need, right? It has, in the order, it has the numeral and the value, which is what we need, okay? So we don't need to do anything fancy there, and we can get into it. Now, in the last video, I talked about how I like to figure out how many times to repeat this numeral, right? That way I don't have an internal loop going. I can just calculate it, send it out the door, be done with it, right? Makes it really, hopefully very fast, okay? For that, I want a const, which is repeat, just like this, and we set that equal to what? Well, it's going to be the number divided by value, right? And that could be a float, so we want to do math.floor, sorry. I was forgetting which one I was using there, but math.floor, math.trunk, right, to round it down. And then we use that. So we go Roman plus equals what? Well, it's going to be that numeral, right? We're sending in the numeral, and we're sending it in a repeating number of times, which is repeat, okay? If repeat is 0, then we get an empty string here, not a problem, right? So we don't need any conditionals in here for that. It's all just going to work. We don't need to take care of that. What we do need to take care of is updating the number for the next loop, right? Otherwise, we just have a runaway loop. So that's going to be number, and we're going to go modulo equals, which we can totally do, just like plus equals, modulo equals value, right? At which point we are reducing it down to just the remainder of whatever number divided by value is, right? That's what the modulo does. So with this, we can totally grab this one because my arguments line up. We put it in here, and it works, right? Again, like 2 separate steps, but it all depends on the data. Maybe your data is different. That's not a problem, but in my mind, it should be the same for all these different functions, whether we are parsing a Roman numeral to decimal or taking decimal to Roman numeral, using the exact same data and just manipulating it to get what we need and how we need it, at which point we can do the work. And today we had to parse that bad Roman numeral, right? It was only additive, so we took care of that. And then from there, we took that number and sent it through and did a correct Roman numeral, right? And that's what this one is doing here. And then we sent it out the door, right? And the beauty of this system, the reason that I separated these is because now I can play around with these. So if the rules of parse bad Roman change, well, I'm only changing this function, right? Not everything inside of here, possibly breaking things, right? If I break this function, if I test it and it breaks, then the problem isn't down here. So I can ignore that, right? By breaking it into pieces, we make it easier to maintain and easier to debug, right? Stuff like that. So this is it, a couple steps, right? But not every solution, hopefully just one good solution. That's what we're going for. If you think so, if you don't think so, if you found another way that you want to share, let me know all that stuff in the comments. Otherwise, today this has been Roman Numeral Fixer, and I will see you in the next one.